define speed and velocity and use the definitions to explain why one of the quantities is a scalar and the other one is a vector. So I hope you'd be able to attempt this one. So I'm going to skip this question at least. Let's take a look at the next one, the part B. A ball is released from rest and falls vertically. The ball hits the ground and rebounds vertically, as shown in figure 2.1. The variation with time t of the velocity v of the ball is shown in figure 2.2. So everything that you need to know about the speed of the ball as it falls on the ground and as it rebounds is given on this graph. In matter of fact, this graph is a very useful tool in order to explain the motion of a bouncing ball, the vertical motion of a bouncing ball, and how does the velocity varies with time, and what should be the control factors. So let's think about it. Initially, the ball is kept at a certain height. Okay, someone might be holding the ball at this point. So initially, the speed of the ball, which in this case it is a velocity because we are representing on the negative y-axis as well. So we are considering the change in direction as well. So when you're holding the ball and the initial speed was the initial velocity was 0, that is being referred to this point. So let me ask you the question. As soon as you release the ball, what happens to the velocity of the ball? Does it increase or decrease? The question was, I release the ball from this side. Initially, its velocity was 0. Now I release the ball from this height and it moves towards the ground. What happens to the velocity of the ball? Okay, that's better. So we can say the velocity of the ball increases. And just before hitting the ground, do you agree that it would be having the maximum possible velocity just before it hits the ground? And what is that maximum possible velocity represented on the graph? How much is that? If I zoom it in, then it would be, see, from 10 to 12, that is being separated by 1, 2, 3, 4, 5 blocks. So what does that mean? What does a single block represent? If from 10 to 12 it is being covered in 5 blocks, then what is one block representing? If you're not able to guess, do it mathematically. And how do we do it mathematically? So what is the separation between these two? It is 2.0. 12 minus 10. And in how many blocks? In 5 blocks. So what does that mean? 2 divided by 5. And do we get 0.4? So this means
Yes, sir.
each single block is representing 0.4. So what is the velocity at this point? And this one is 1, 2. 2 lines above 10.0. So should that be 10.8? Because it is 2 lines above 10.0. So after the first line, after the first small square, it would be 10.4, and after the next small square, it would be 10.8. So this is 10.8. And then the next one would be 11.2, and then the next one, the second last one, would be 11.6, and then the final one would be 12. So just before hitting the ground, the maximum velocity that is possible for this ball would be 10.8. And then what happens? At that time, the ball collides with the ground. The ball hits the ground. And as the ball hits the ground, it then rebounds. And let me ask you the question first. At what instant of time the ball touches the ground? At what instant of time? At 1 second, 1.1 second, 1.2 second. At what instant of time the ball touches the ground? So let me draw a straight line over here. You might be able to answer in a better way. That is representing the time at which the ball hits the ground. And how much time is that? If I check it from the x-axis, then it is one block ahead of 1.0. So that would be 1.1 second. Because you see, from 1 to 2, these blocks are being separated by 10 small squares. So each small square is representing 0.1. So this is the second information. Okay, so far I've not even seen the question. We are just collecting the data. We're just analyzing what is the information that can be obtained about the motion of the ball as it rebounds from this graph. We're just analyzing the graph yet, and it is a very important one. So we can say the ball touches the ground at the instant of time, which is 1.1 second. Then my follow-up question is, what is the time at which the ball rebounds from the ground? And how do you know what is the time at which the ball rebounds from the graph? It would be the instant at which its velocity will start to decrease. Because as it's moving up, its velocity will start to decrease. And once the ball moves up, its velocity decreases, and as soon as it reaches the maximum height, okay, so it rebounds, is going upward, its velocity decreases, and it might be reaching probably at this point, might not be reaching at the same height, it might be reaching at a lower height, because some of the energy would be wasted. So what is the instant of time at which the ball rebounds? Not the instant of time at which the ball touches the ground. I'm asking about the instant of time at which the ball rebounds. So let me draw a line here, and we might be able to comment better. This is the instant of time at which the ball rebounds. And that instant of time is, if I zoom it in on the x-axis, then that instant of time is 1.2 second. So the first one was, this one was 1.0, the second one was 1.1, and this one is 1.2. So the ball rebounds, or we can say the ball starts to move upward at 1.2 seconds. Now the most important question is, if the ball touches the ground at 1.1 second, okay, touches, let me write it down here as well. The ball touches the ground at 1.1 second, and the ball rebounds or moves up, starts to move up at 1.2 seconds. Then the question is, why is the time delay here? We have a delay of 0.1 second. Explaining here is, as soon as you drop the ball from a certain height, and let's say it reaches the ground, it hits the ground at 1.1 second. Now the next thing is, in this case, which is represented by the graph, velocity time graph that we have seen, it gives us the information that the ball does not rebound all of a sudden. Matter of fact, first the ball compresses and then it restores to the original form, it then stretches, and then it moves upward. So there would be some time consumed as the ball compresses. When it is still in contact with the ground, it compresses and then it restores to the normal shape, and then it lifts off from the ground. And I mean, we have plenty of slow motion videos on the YouTube where you could see that it takes a lot of time for the ball to compress. As it hits the ground, it compresses, it gets shorter, it gets narrower, and then it extends or stretches just like a spring, and then it lifts up. So the time at which the ball was rebounded was 1.2. From the graph, it was 1.2 second. So what happened in 0.1 second, the remaining 0.1 second, the ball was being compressed and stretched, which is due to the elastic nature of the ball. So this is a point where the ball started to rebound and it's moving upward. Its velocity is being decreased, and decreased further, and at this point the velocity of the ball reduces to 0. And what is this point? This is a point where the ball reaches a maximum speed after the rebound, after the first rebound. Sorry, not the maximum speed, maximum height. So this is a maximum height that the ball has reached after the first rebound. And you know this thing, when the ball reaches a maximum height, its velocity would be reduced to 0. And that's why its velocity is 0 at this point. And what happens after that? Now this ball again starts to go down. So it might move at this point, and as it goes down, its velocity would increase, further increase, increases once again to a specific limit, and this is the point at which the ball hits the ground. So it has the maximum speed just before hitting the ground, and this time, after the first rebound, this speed is not the same, is not as high as it was previously, because some of the kinetic energy would be converted into some other forms of energy, and the lower the kinetic energy, the lower speed would be possible. So this is the information that we can get from the graph of the rebound. So if I draw, once again, I remove everything and I try to draw yeah, represent the situation here. So from 0 to this thing, so this part is representing the ball being released from the height, and this is a point where the ball rebounds and goes up. So ball is being rebounded and is going upward, and this point is the point where the ball reaches the maximum height. So reaches maximum height, and at maximum height, the velocity would be 0. And once again, above that, the ball's velocity is increasing, and there you have a maximum point, and this maximum point is once again the velocity just as it touches the ground. So this is your point where the ball reaches the ground. As it reaches the ground, this is that point. Okay, so this was a brief introduction of the graph of a ball that rebounds off the ground. Let's check out the questions. So air resistance is negligible, which means if we find the gradient would be constant, and we can see from the shape as well, because we are having straight lines, and that is possible only if the acceleration is constant. And acceleration can be constant only if air resistance is assumed to be negligible. So what is the question? Without calculations, use figure 2.2 to describe the variation with time of the velocity of the ball from 0 to 2.1 seconds. Let me check out what till this point, 2.1 second. Okay, till this point. So we have to explain this shape, this one and this one. Okay, so this one that you see here is just connecting the 2 points, and it is not a vertical line because we have a time delay in the collision. So let us answer this question. So we break it down into the first part, and let's say from 0 to 1.1 second. And if the velocity is increasing at a constant rate, what do we call that? Can we call that uniform acceleration? You can phrase that. The velocity of the ball increases with constant acceleration till 1.1 second. Well, plenty of ways, but the key concept has to be there. You have to mention that the velocity is increasing at a constant rate, or you can simply say the ball has constant acceleration. Until what point, you have to mention that as well. So at 1.1 second, the ball hits the floor and it bounces. And that's why we have a change in the direction. So you see, at this point, the ball hits the ground, and now the velocity of the ball would be reversed. The direction of the velocity would be reversed. So the ball's velocity would now be negative. If you assume that when the ball was coming downwards, the velocity is positive, and as soon as it touches the ball and it touches the table or touches the ground and it rebounds, then the velocity of the ball becomes negative. And that's why we have this thing below the y-axis, or sorry, below the x-axis, which is towards negative y-axis. Ground and rebounds, and the direction of the velocity changes. And it rebounds, if you want to add, you can. It rebounds at 1.2 seconds. And as it rebounds, it once again decelerates, because after rebound it'd be moving upward. Okay, the ball would now be moving upward, so it would decelerate, and its velocity would be reduced to 0 at the same rate as before. And let me add this thing. Alright, so what we have explained is, in this part, the ball is going towards the ground, and then it rebounds. It hits the ground at 1.1 second. It rebounds at 1.2 seconds, and it rebounds, it goes upward. It goes upward. So in that case, as it goes upward, the velocity of ball would slow down. They would decelerate. And at 2 second, which one is that, 2 or 2.1 second, the ball reaches once again the maximum height after the rebound. And that is a point where the maximum height, where the velocity of the ball is reduced to 0. But the thing is, this portion is representing when the ball is moving towards the ground and the velocity was increasing, so we call that in this stage the ball was accelerating. But this one is the portion in which the ball is moving upward. After the rebound, it's moving towards the same point. It may not be reaching at the same point because some of the energy would be wasted, but it's trying to reach the same point. It's going upward. As it goes upward, the velocity of the ball decreases, and at 2.1 second, when it reaches the maximum height, it decreases to 0. And then, since at this stage the velocity of the ball was decreasing, so we call that deceleration. But the thing here, the last part that we mentioned over here, this one, and at the same rate as initial, when it was falling towards the ground, and the ball decelerates and eventually comes to a halt, but at the same rate. What does that mean? It means whatever the previous or the initial acceleration was when the ball was coming towards the ground, in terms of magnitude, that acceleration equals to this deceleration. And how do we know? Because if you have velocity time graph, then acceleration or deceleration is calculated from the gradient, and these two lines have same gradient because these two are parallel lines. You can even check it with the ruler. These two are parallel lines and they would never cross each other, and parallel lines means they have same gradient. If they have same gradient, they must be having same acceleration. So in terms of magnitude, acceleration equals deceleration.